Thanks, Ben. I really appreciate it. And I thank you all for being here in the room and in the Zoom. So the talk, I wanted to focus it on how, and on really one specific type of demand flex, which is virtual power plants. I think a lot of the lessons and the benefits of virtual power plants, they do speak to demand flexibility in general. So start off, how smart tech can save California's grid. I know a dramatic title, but I think it applies more so to Advanced Energy United as a whole. And again, we'll be talking about one specific type of smart tech more than anything. So here's a quick agenda. So I'll introduce myself. We'll talk about VPPs and what they are and why do they matter, but then in the big context, how they work, and then we'll talk about a little bit of the policy momentum behind VPPs and the barriers that still remain that we want to deal with. So first off, about me, I am a proud UC Davis grad. I did my undergrad here, graduated with a BS in economics and international relations. And here's, right now I currently lead our California legislative and political engagement for Advanced Energy United. So that means that I'm in the Capitol lobbying legislators, working with coalitions to come up with policies to advance the goals of Advanced Energy United, which is a national industry association I'm going to a little bit later. But the way that I got here quickly is that I started at UC Davis as a mechanical engineering major and trying to figure out what to do. And I took some engineering classes and I quickly found out that it wasn't for me. And I also took introduction classes across the board. And I really liked political science at the time. So I switched my major to political science. And I quickly found out once I got into the upper division classes that I hadn't been trained to write very well at that point. And the 20-page papers kind of got the better of me. So then I did a little bit more course correction, ended up in economics, kind of a mathy social science, right? And so then during UC Davis is where I got introduced to policy advocacy through CalPERD. And we did a lot of advocacy here on campus and the visits to the Capitol, lobbying visits and whatnot. And that's what really sparked the passion to go into public policy initially. So I guess just for the students out there, it's good to just discover different paths, do internships, take clubs, and you can find your path that way. So after Davis, I started working in the California State Legislature, where I worked with a couple of different legislators, all kinds of policies, and ended up working for the last 3 to 4 years for the California State Senate leader, Senator at the time, Tony Atkins, and worked on a variety of issues with her, both in the Capitol, and I also did a lot of political work and campaigns. But then I also wanted to just understand more about the business side of things, how the rubber meets the road, and how services and goods are delivered to people on the ground. So I decided to do another pivot and do my MBA at Georgetown University. And there I really got introduced to the world of entrepreneurship and startups in clean tech and clean energy, work with different startups in that world. And it really became passionate about the impact that innovation can make in the world. So after that, I returned to Sacramento to become the California lead for Advanced Energy United. And I forgot to mention, I'm originally from Lima, Peru. I see a picture here of Miraflores, which it's not quite where I grew up, but it's a really nice part of Lima that I recommend that people visit, and I go there all the time. So we'll go back to visit family often too, back to Lima. And just lastly, I'm a co-founder as well of PeraWatt Energy, which is a startup that is focused more on the hardware side of things. We're partnering with a national lab to commercialize a technology that they have there that is about manufacturing next generation, high efficiency magnetic materials that can be in all kinds of power appliances and devices to make power efficiency, power conversion more efficient, which is a key need these days, especially as we electrify everything. I'm happy to talk more about that maybe after the talk with any of you. So please feel free to reach out.
You have your sample, right?
Oh yeah, and so for PeraWatt Energy, so here's a sample of exactly what we're looking to commercialize, which is probably hard for the Zoom folks to see, but I'll pass it around here in person. It's the material itself. So it's a new material composition that was developed for over 10 years at a national lab, and now it's at the point of commercialization. So we're looking to bring it into the market to just bring a new efficiency jump to all kinds of energy devices and systems. So I'll pass it around so you can see, this is an inductor. So you can see here the inductor core and feel innovation.
Palm of your hand.
Palm of your hand, exactly. So yeah, happy to talk about that. But quickly coming back to Advanced Energy United, right? So Advanced Energy United is a national industry association. We represent businesses, clean energy and clean tech across the electricity grid, and we try to have a macro view of the grid. So we represent businesses at the utility scale generation, solar, wind, utility scale batteries. We also represent folks in the transmission space and distribution, and behind the meter, like the distributed energy resources that I'm about to talk about, batteries, EVs. And we also have large energy buyers that need clean energy to be available. So we really do this in our mission to achieve 100% clean energy, and we'll do this by providing credible research. We know about the technologies because we work with the businesses developing them, and we work on developing policies to really build the market. And just quickly, so the advanced energy industry is huge in California and growing fast. And for those out there looking for jobs, you can see here 152,000 jobs in electricity generation, 24,000 in advanced grid, 300,000 in energy efficiency, and so on. So it's a very big industry delivering not just jobs, but benefits when it comes to affordability, when it comes to the grid. It's an exciting space to be. So virtual power plants, right? What are they for those who don't know? First, we have a bit of a academic / statutory definition. They are an actively coordinated aggregation of distributed energy resources that are dispatchable and can balance electricity demand, supply, and reduce or shift demand. We'll break that down, but quickly, they really depend on these distributed energy resources, which some of which are outlined here. That's rooftop solar and battery storage. That's electric vehicles and chargers, smart thermostats, heat pumps. So really these smart energy devices that can be tapped into, they're connected to the internet and can be tapped into so that we can virtually regulate how they consume energy. That opens a world of possibilities. So I have this graph here to compare virtual power plants to the traditional system, some key differences. So in the traditional energy system, we have generation that happens really far away from the load centers, the consumers, right? We have big solar fields, wind farms, nuclear and natural gas and others. And so they're big, large utility scale generation. They're connected to the transmission system, travel for many, many miles, get to the distribution system, and then go to people's houses and businesses. It's a one-way street here. However, with a PPP, it taps into these now DERs that are being adopted across customer classes. You see here in homes, of course, rooftop solar and storage. We have dishwashers, thermostats, commercial, similar, other DERs, EVs themselves. Now they're not just receiving energy, but they can give energy back through bidirectional charging, right? So all of these devices across hundreds of thousands of homes and businesses can be plugged into, can be connected through advanced algorithms and software by a virtual power plant aggregator. So this can be a utility, it can be a third-party company like a Sunrun or a Renew Home, and the aggregator will have individual contracts with all these different customers and say, hey, can we tap into 1 or 2% of your battery when the grid's in need, or change your thermostat slightly when the grid's in need or when we need energy, and we will pay you for it. So doing that across hundreds of thousands of distributed energy resources and customers, it creates a big resource that is equivalent from the eyes of the grid to the large scale generation. So that's kind of a summary of what it is. And then here's what that can deliver for the grid in a quick summary is affordability, reliability, and decarbonization, right? And this is kind of an overview that will really flesh out go forward, but things like affordability, because by generating power at this stage, you just need a little bit less transmission and generation, which is a very expensive part of the system. And that delivers affordability benefits. And so, have reliability, decarbonization, all these great benefits that will break up going forward. And also, VPPs are already around, right? They're not brand new. These are just a couple of examples of VPPs that are in place right now. So we have the SGS, which is a program that is ran by the California Energy Commission. It's statewide, launched in 2022, taps into all kinds of technologies and it has the capacity to deliver over 500 megawatts of energy. And it's got over 260,000 customers enrolled. So it's a large virtual power plant program. So this program works by the Energy Commission contracting with individual third-party providers. But we also have virtual power plants run by utilities, right? One example is the PG&E and Sunrun partnership. And it was launched in 2023, and PG&E recently got a $15 billion loan from the DOE that it would in part go to bolstering their VPP program. And so this capacity will be growing through this program. And then we have a new exciting partnership with just NRG and Renew Home. This one's in Texas. They're saying that they'll deliver a gigawatt of capacity by 2035 using smart thermostats. So there are, these are just a few examples of countless VPP programs out there. And by the way, I prefer to ask questions as we go along in the clarification. So taking a step back quickly, why do they matter? How do these things really connect to the larger grid, larger problems that we have? Here's to start off, it's a big problem. The biggest problem right now in energy policy in California is bills are just too damn high, right? We have electricity rates rising rapidly. You see here the 3 IOUs, investor-owned utilities in California, and the rates compared to the national average. So they haven't just been higher in general, but they're rising quickly. So you can see here too, since 2014, PG&E's bills have risen by, or rates rather, by over 100%. And SDG&E and SoCal Edison are not that far behind. And now there are a lot of reasons for this. Here's a breakdown of the electric rate components. See here, generation, which is the energy capacity itself, it's the largest portion. Then distribution and transmission, which is the grid infrastructure components of the rates, are very large as well, right? And then we have smaller portions here, but to really tackle this electricity rate crisis, affordability crisis that we have in California, I think we need to target these bigger sections of the problem or of the system. We need to manage the increasing rates. And so this is a critical slide here that I want to walk through to explain some of this. So we have on the y-axis here the capacity by hour on the x-axis that the grid it needs over a whole year. And so this is the famous duck curve, right? So we can see here that consumption by hour in 2022 varied this way. This is 1 a.m., 2 a.m. So overnight, people are not consuming a lot of energy because they're sleeping. And energy consumption keeps going up. And the peak is around the 6, 7 p.m. mark in 2022. So that's when people are getting home and turning on all their appliances, charging their cars and whatnot. And just with the electrification of everything, energy consumption is just generally, it's just going to keep going up. So if you see the areas under the curves are just getting bigger and bigger by year. So we have 2022, we have 2025, it's an orange curve. That's already a little bit higher. And the projections for 2030 and 2035 are substantially higher. So we're just going to consume a lot more electricity. And that really piles up at the peaks. And important to note that grid infrastructure, so the poles or wires, they are built to the peaks, right? They have to handle the biggest consumption points. And with the peaks rising, we're just going to need to build that much more infrastructure. And this is something that, it doesn't look like a lot here, but infrastructure is one, again, very expensive to build, and also takes a long time. So there are two key problems here that are driving utility rates, right? Just more consumption of energy and the need to build more grid. And so we go into VPPs, or even a step back, we go into distributed energy resources, going back to these smart devices. They can help with this problem by shifting peaks. So we see here, the baseline energy demand is the peak, but with a distributed energy resource managed through a virtual power plant, we can shift that peak to before and after that period, effectively lowering the need to build that much infrastructure. See, again, we can do this through EV chargers, smart thermostats, smart water heaters, and whatnot. And we have other ways the ERs can help too. Can help shape the peak, which just means that consumers with their own solar and storage and home or businesses, they just need to consume less energy from the grid. So this is from the perspective of the grid. Previously, consumers were here, and now they just need to consume less from the grid. We have also shedding. This is a large load industrial, and shimming, which happens at the second level. But I think that these two are the really big ones to know of how DERs can address this problem directly. So that leads us to the benefits that virtual power plants, the aggregation of these resources and those methods can deliver for California. This graph is from a study by the Brattle Group of the projections of what virtual power plants can deliver for the state. So what we're talking about peaks, right? So the existing capability of virtual power plants right now, which all the programs that we have that are great, is around 1,600 megawatts of capacity delivered to help shape those peaks. But by doubling down on virtual power plants, by using things like behind-the-meter batteries, smart thermostats, electric vehicles, we can quintuple that capacity by 2035. So that's 7,000 megawatts of peak energy that is delivered, and more to the point, that generates massive savings for consumers. So we see here, these are all the VPP benefits to the grid as avoided system costs. So with virtual power plants, we need to generate less capacity in the traditional way. We need to build less transmission, deliver less megawatt hours energy itself, and build less distribution. And instead of that, we would spend some money on the VPP's architecture itself, but then the bulk of the money that would be spent on the system at this point would go to VPP participants. So those people that are being paid, those people are businesses and institutions like UC Davis and community centers that may have rooftop solar storage. So those VPP participants would get payments for delivering energy to the grid. Now this can look like $500 to $1,000 per year for those VPP participants for sharing their energy with everybody else. And because we would be using the system more efficiently, again, less transmission, less distribution, we will see $50 million per year in savings for everybody else. Even if you don't have distributed energy resources at home, even if you're not plugged into a VPP. So I think this is really the conclusion of exactly what we would be getting by doubling down on virtual power plants. So maybe I'll stop there on the benefits, because the next slide is going to get a little bit technical, and then we go into policy. But I don't know if there are any questions here or in the Zoom about exactly how these benefits are delivered to the system.
I don't see any questions yet on the chat, other than there was a question about whether we started or not. Sorry, we did get a late start. That was just to make sure we people in the room got a chance to eat lunch. But are there any questions from folks online or in the audience?
Yeah, I have one. So
Yeah.
in the previous slide, you talked about 4 different graphs. Yeah, the first one, no, the previous, the 4 different graphs.
That one?
Yeah, this one.
Okay.
So the first scenario of shift in the demand. So do you plan to do it mainly through batteries and storage systems, or like what's the technical aspect of it? Like how can you shift that much of a demand to a different time?
Yeah, I think, well, this can be done with any device where the load, the consumption of it can be managed in a different way. So I think a lot of it will be batteries, since that's, very manageable demand. It's a lot of energy there that could be shifted, but smart thermostats play a big role too, because that's also space heating and cooling takes up a lot of energy. But it's really with any of these distributed energy resources. Now, this is an illustrative example, right? We don't have megawatts here. This is not saying that, it's not saying that we're gonna shave, I guess this is not specific to how many megawatts we're shaving. It's just saying how it would be shaved. It's shaved by pre-cooling a house, say in summer, so that it's not being cooled right when you get at home. But say the household, a smart thermostat, kind of knows when the family is going to be home. So it's going to be home at 6 p.m. But everybody's going to be home at 6 p.m. So then the house gets pre-cooled automatically because they're connected to the VPP, and the VPP knows the behaviors of that family, and knows when energy is most expensive or when it's most consumed. So the VPP automatically pre-cools the house for a lot of people. So then you're shifting that demand that would have happened at 6 p.m. to like 4 or 5. And similarly, maybe as you get home, you plug your EV in, instead of it charging at full capacity as soon as you get home, it's programmed because it knows that you're going to be there all night. So it waits to do the full charge till a little bit later at night. So that's exactly how it works, but that's how it can work with any DER. That's a good question.
So my understanding was that VP participants are those who have batteries and PV systems, so that they can deliver energy to the grid. But you mean that other participants, like other households, are also eligible, like those only have smart thermostats, so that their load can be controlled. Am I understanding right?
That smart thermostats can participate in VPPs?
Yeah, without any batteries, without any solars.
Yeah, because their smart thermostats are controlling in an active way, in a virtual way, how the energy is consumed in the home, the energy from the heat pump, or even the even the gas-fired.
So incentives for households consist of some rewards for delivering energy, as well as some kind of compensation of being controlled, right?
Yeah. I mean, I think that's a good point. It's not necessarily that giving the energy back to the grid. It's just controlling how energy is consumed by the people by the customers, right? By a home. So if you decrease their energy consumption in the eyes of the grid, it's kind of the same as giving electricity back to the grid. So that is worth money. That is worth value to the grid. So the VPP can actually bundle that demand management and sell it into the market, and that's a key value proposition of the VPPs.
So Edson, just to build on that,
Yeah.
right? That what you're talking about is market integrated, right? Where you're selling this service into where the transmission and distribution, the folks who manage the transmission, the CAISO, California Independent Service System Operator, is scheduling that resource, right? And if you can do that on a reliable basis, then you can achieve the savings that you're talking about, the avoided cost of upgrading the transmission, right? You mentioned that at the very beginning, there's that line. If we can avoid having to increase those costs
Yeah,
on that infrastructure, that's where we get our savings. And I think you fast forward to another slide you just had, keep going. Yeah, we can save that 194, I'm assuming that's, $1 million, right? Of avoided cost, but we only get it if we never, ever call on those. In other words, that resource that we're replacing it with the VPP is 100% reliable. Right, because otherwise we're gonna call on that transmission resource and we're gonna need transmission at some point to get there.
yeah.
And not all resources are reliable, like fossil gas power plants will go, they have a capacity rate, they don't run 24/7, 365 days a year. But how, when we look at the examples that you use and we talk about VPPs, how reliable are they viewed as a resource? When compared to, I guess, the traditional resource? I think that's probably helpful for us to discuss.
Yeah, I mean, I think you're speaking to the main thing to work through for VPPs, right? Like one, how reliable they are, or they have to be, or they can be. And not all VPPs are built the same, right? There's very different models of VPPs using different technologies and guaranteeing different dispatch methods for different durations. And some of them can, depending on the customer and the agreement that's in place, can guarantee that energy is going to be delivered, right? If you can say like, if the VP aggregator can build contracts with maybe like large customers where it's guaranteed, say, when I call on you for you to turn your equipment off for an hour or 2 or 3 or 4, that it's going to happen, and that's establishing contract, then that's a lot more reliable than if you have contracts with 100 households about you saying that you can control their smart thermostats, but they can override it. Right, so that's a very unreliable VPP, because maybe you can do it sometimes, but it can be overridden, and it's not that big of a population. So I think ultimately, yeah, the reliability, the deliverability of VPPs, and how that plays into how the state regulates that, qualifies that through the resource adequacy process, is a key barrier that we see it as a barrier because the state energy agencies, for the most part, are using the method of reliability that has been used for, just the way that things have been for the decades, which is the traditional power system, utility scale generation and whatnot. And for VPPs, you just need to be a lot more sophisticated because they're so different, right? And distributed, and they're tapping into different devices. And so to guarantee that reliability and deliverability, and we'll get to this later, is that we as Advanced Energy United are calling on the energy agencies to proactively work on this together, because there's 3 main agencies that each of them are very aware of the issue and have been talking about it for a long time, but we think are not necessarily like working together on a concrete plan to build a framework for to really assess the reliability of VPPs in a way that understands how they can work or they do work. But I mean, I think that's the crux of a lot of this, and then we'll get to it later, but it's a great point to make it. And I guess to the point of like the complexity of VPPs that need to be accounted for and why the regulations need to be updated, going to how do they work. I mean, I won't spend too much time on this because these are very dense slides, but these are just 3 models of how VPPs can work. One is a turnkey VPP, meaning that the vast majority of the operations of the virtual power plants are handled by a third-party operator. So this is like again, a Sunrun or a New Home or an Energy Hub or these companies that provide virtual power plant services. They handle most of the things. They operate the devices, they enroll the customers, they pay the customers, and the signal the off-taker means that it's just the signal from the grid that would activate the VPP. That will still come from the utility or the wholesale market. But a lot of it, but the rest of the operation is driven by this third-party company. Now there's a utility managed, but third-party operated virtual power plant. So here, the utility is a lot more involved and is working closely with a third-party aggregator and potentially a separate entity like an OEM platform operator to do the VPP functions. And we have also utility orchestrated VPPs, but the utilities are really handling the bulk of the operations of the VPPs. And these are just a couple of examples, and you can go into a lot of different ways to how utilities and businesses can work together to manage the VPP from the grid point of view. And then from the customer point of view, there are a lot of things to consider, and these can all be very different depending on the VPP model too. Not to walk through all of these, but the questions are: who owns the device? If the customer buying it on their own and then they get tapped into, or it can be financed by a third-party company or other models. And when are things being dispatched? How does that contract relationship happen with the customer? Who can participate in the VPP, under what terms? It goes into how reliable can it be, because you have to put that in the contract as well. Right? Who controls the dispatch? Again, third-party operator or utility, or how much control does the customer have? And what are the incentives, which is key to keep customers actually in the program and preventing them from overriding it? And how does that balance with the compensation that the VPP operator would get? So it's just, I guess, to the point that how reliable are VPPs is. There's a lot of things to consider to make them work and make them reliable. So going, I think, to the policy momentum that we're seeing now, and really where we need to get to. In 2022, we saw a real pivot, laying the groundwork for load shifting on virtual power plants, which are a key way to shift load. So there was this big energy deal, right? It's two big bills where California had seen a lot of tough times in its grid in 2021 and 2022, because we had hot summers, we had wildfires, and we had PSPS events, public safety power shutoff events. And there was the question of whether we still needed Diablo Canyon. And so through the negotiations at the time, it was decided to keep it open. But at the same time, people thought, how do we stop depending on not just this Diablo Canyon, but just dirty energy resources and load shifting resources, distributed energy resources, were really identified as a key way to do that, and that California really needed to move the ball forward on this system that we're talking about here. So they created a few programs. One is the Distributed Electricity Backup Assets Program to fund new DERs, new distributed energy resources, batteries, and others to provide the supply. They created the Demand Side Grid Support Program, which I spoke about earlier. It's actually a statewide rich power plant program, and they mandated the Energy Commission to establish the load shift goals that Ben mentioned. And so the Energy Commission came up with 7 gigawatt goal by 2030, 2023, in this great report that they had, and that's really leading to where we are today, which I guess going off with the Energy Commission side. Now we have more momentum, right? We have a Demand Flex Summit that I mentioned initially. That's in May 22nd, and we're very excited about to see how much progress we have made for the load shift goal. How are we best using all these load shift resources and what we can do moving forward. I have here in the regulatory space too that the PUC. I don't have fun pictures for the PUC. If you have any, let me know. But they have been thinking about this for a long time too. And I think it's worth looking at dockets too in terms of how they think about this. But this year in the legislative front, we're also seeing a lot of momentum for these resources. Right? We see AB 740 by Assemblymember Harabidian. It calls on the energy agencies, on the 3 of them. It's tasking the CEC, but it asks the PUC and the CAISO to be involved too, on how to really, what are the barriers right now for VPPs with reliability being one of them. And how can the state really work together to update their framework to make sure that they get all the benefits that we talked about earlier. We have AB 44 by Member Schultz, which makes the process by which the load serving entity like a utility can guarantee to the Energy Commission that their PPP programs are actually going to be there and are reliable. And so right now, they can't do that. They can tell the Energy Commission, hey, it's a guarantee that our demand is going to be lower because we have a P program. So Energy Commission, you should lower our electricity demand forecast. So that process is in place right now, but it's not that clear for providers or load serving entities. The bill seeks to make that more clear and just encourage more participation in P programs. And then we have SB 541 by Senator Becker, which takes the load shift goal that was developed, 7 gigawatts by 2030 load shift goal that was developed by the Energy Commission, and allocates it to the different load serving entities. That is, there's different utilities and choice aggregators, publicly owned utilities, to in a way hold them accountable for them to actually be meeting the goal, like for them to do their part in meeting this goal by doing things like establishing virtual power plant programs or doing dynamic rates or doing other things. So these bills are active right now, so I guess I encourage folks to look into that and make your own assessment to call for advocacy right now. And the bills really speak to things that still need to be done. And that's the barriers that are holding us back, but really things that we need to work through. It's another complicated slide, but it basically talks about the roles of the energy agencies right now. The Energy Commission, they forecast the demand that California will have in the future years, and also and not just statewide, but by load serving entity, by utility, and the CAISO, it takes that demand and it plans out how much transmission we have to build, and also establishes a market by which energy can be traded. And the PUC also takes that demand and says, okay, utilities, you're going to have X amount of demand, so you have to buy that amount of power, and it has to be reliable. And so really the process of PUC telling those utilities to purchase reliable power is in a way what we call resource adequacy, so resource adequacy really is California's way of making sure the grid has enough power to meet demand, right? So it's both a technical standard ensuring that the power that the PUC mandates or requires the utilities to procure is reliable enough, but then it also tells them how much they need to provide, and they have a buffer that they have to buy in addition to the projected demand to make sure that no matter what happens out in the grid, any emergency events, that the power is going to be there and people's lights are not going to shut off. So it's an important measurement, right? Like we want our lights to stay on. And so it's a very technical and very complicated way to measure reliability. But it's a measurement that has been designed for utility scale power plants, the traditional system. And as a result, most virtual power plants are not already compliant, meaning that right now they're not considered, it depends on the big power plant, but largely they're not considered to help fulfill utilities procurement obligations. And so they're not considered, they don't provide value to utilities if they're not considered reliable enough per the PUC. And so that's really, I think, what one of the cruxes of this, right? Like energy agencies working together to update the framework to take into account how PPPs do work or can work in the future. So here's a summary of some of those barriers by energy agency. But I guess in short, it's just a complicated topic, and there are a lot of things for each energy agency to work through. This is from a report done by LEAP, which is a big company too. But there are things related to customer data access. So part of assessing reliability of VPPs is knowing, is the grid knowing how the devices function behind the meter, let's say like the devices in people's homes, and not having visibility into those devices it is an issue or can be an issue. So it's just work out ways to have better visibility or have better ways to estimate how they're going to perform. Then, you know, in the markets, we also agencies can do better things to value the capabilities of VPPs. And of course, there's the methodologies of forecasting and measuring VPP participation. Ultimately, you know, I'm well past my time, but I think these are things for more discussion that, you know, we're happy to talk through with folks and continue to engage on. And just back to the broader point, with VPPs, you know, the power can belong to the people, it belongs to the people. And so I think we just want to fully leverage this new, relatively new way to deliver benefits. And stop there for, oh, thank you. And feel free to reach out to me. Thank you for having me. And I had a Q&A slide, I thought, but anyways, I'll leave it there. But yeah, that's what I have for today. But I'm happy to take questions and continue the discussion at another time too.
Well, we have about 5 more minutes for Q&A, but let's first pause and just take a moment to appreciate you spending your time and putting this presentation together. Thank you. I know I saw Ansel on there earlier. I know he's probably going to ask you a question about what's happening in Australia and if there's any lessons that we can learn from them. So Ansel, I'm giving you a little bit of time here to come up with your question, but in the meantime, I do have a question, and then maybe we can also open it up to others. Kind of, you mentioned one of the bills was talking about dynamic pricing, and of course that's another approach towards driving towards demand flex. In fact, some people, when they talk about what the definition of demand flex, it's like central to this has got to be dynamic pricing, and so what are the implications of that to VPPs from your perspective? Because if you build that into the rate structure, if you give access directly to the customers to that dynamic rate, then they may not, it may just go further upstream and affect the load forecast, which then, you know, supersedes all the other kind of concerns, right? It reduces RA requirements, it reduces the need to build the transmission, the distribution. If you can reliably adjust that forecast because you now have a load, you have a dynamic pricing signal that kind of embeds, especially with these applied standards that are coming online, that basically it'll encourage customers to do this by themselves without the need for an aggregator or a VPP or an orchestrator. I don't know if you can comment on that kind of dynamic, and there's almost a tension between market integrated resources versus load modifying resources or resources that respond directly to these dynamic prices.
Yeah, I mean, I think that is a great point, right? I think a lot of discussion around load shifting ends up in how to do this in a more an elegant way, right? Like the prices shifting according to the grid demands by the minute, and the price, like the consumer is not even involved behavior-wise, right? Just taps into the device. And I think that is a good thing that we should be working towards. I know the energy agencies are discussing how to work towards. I guess where we stand is that we just need an all of the above approach and dynamic pricing. I am not in the dockets, but from my understanding, the way to set that up in an elegant way to get to that end goal is just going to take a lot more time. And it's it would be a very complex back end structure to orchestrate. And so I think as we work towards that, we could take advantage of proven methods right now of getting customers involved, which are maybe specific VPP programs or schemes. But I do think that there is a way to do both, at least for now. Maybe until we get to the larger vision, that's just from my understanding, yeah, I think it just seems farther away than maybe the ideal, right? And so I think this is a way to take advantage of load shifting resources now, because the companies have expertise in it, whereas dynamic pricing, I think we just need to learn a lot more about how that would work. But I think it compatible. Yeah.
I think,
Can you repeat the question that he asked?
Oh, yeah.
yeah, so one of the things that we have been thinking about is with VPP, I think, is there a way to distinguish VPPs which only respond to emergency event-based, like whenever the temperatures are high in California, you're gonna have a high load. But let's say a customer wants to shed load every day of during peak time. Like, is there that kind of distinguishing factor between VPPs where you have a continuous motivation to shift versus wait for that very extreme day where the grid really needs it and like you have all the resources pulled together?
Yeah, so the question is there a distinction between emergency load shifting for WPP versus everyday load shifting for WPP? I guess the difference is the signal, what's causing the signal to go out to the customers and to activate the load shifting, right? And for emergency situations, because they're by definition kind of one-off, it's hard to integrate that into the market. And so I think that let's see, I think the difference is, yes, how much value you can put behind each of those types of load shifting from the provider side, and whether they can sell that value into the market. And so for emergency, because it's one-off, like it's not a consistent thing. Whereas if a VPP provider, their offering is everyday load shifting based on price signals, then that's something that is a more reliable thing to be able to sell to utilities. They deliver that power. Maybe that's one way to distinguish it, but yeah, I think at the end of the day, from the customer side, it's kind of similar.
All right, it's a little bit past 1. So if folks have additional questions, I do have more questions for you. There was a recent, actually, one of our students, two of our students wrote a paper on what they're doing in Australia with some of their load flex programs that we might be able to learn from California. So I'm happy to share that paper with you. Ansel was one of the co-authors of that, and I know he was interested in that question. I have some questions about the recent blog that came out of the Haas blog, talking about the role of potentially data centers playing a role in load flexibility, and kind of wondering how that fits with programs, PPPs from your perspective, and even some of the legislation that's potentially being developed now. But I don't think we have got time for that, so we're just going to have to take that offline. But the good news is that your contact is up on the screen right now, so people can capture that. And your talk is recorded, and so we'll post that online shortly, and hopefully within a week, and we can get the word out. But thank you again one more time, Edson, for coming today and sharing your presentation with us.
Thank you for having me. Appreciate it.